All right, now we are going to move on to cones. Cones don't have quite as many lateral faces. The lateral face or lateral surface of a cone is the actual cone piece, the part you would hold if you were holding an ice cream cone. And so all of this space here is your lateral face or your lateral surface. So when we are finding the surface area of a cone, we have a few pieces of information we need. One, it's a circular base, so we are going to need the radius, of course. And so if you look at it broken down and flat, this would be your radius. And then we will need our height, which with any of our shapes has to be perpendicular to the base. So that is the height. And then we need the slant height, just like we did with the pyramid. So that's going to go along the outside. So that's the length of the tip of the cone to the edge of the cone. From the tip of the cone to the edge of the cone. Wow, tongue twister. From the tip of the cone to the edge of the cone. So on a flattened cone, that would be this piece right here. Go from the tip all the way to the edge. Okay. Okay, now for the formulas, your lateral surface area, so just if you were wrapping your cone in paper so that your ice cream doesn't melt onto it, think about Baskin Robbins when you get a cone. There's paper wrapped around the edge usually. That lateral surface area is going to be pi times the radius times the slant height. Pi times the radius times the slant height. And then for total surface area, that's going to be the lateral plus the base, just like everything else we've done, lateral plus the area of the base. So broken down individually, that is going to be pi RL, which is the lateral, plus your base is a circle, and it's just one circle, it's not a cylinder, pi r squared. So lateral, pi times the radius times the slant height, total surface area, that lateral plus the area of your base, which is a circle, pi r squared. So let's look at an example. We have a cone here with a height of 12. That's not the slant height. Your slant height is over here. And a radius of 9. Now remember, this height is perpendicular to the radius. So what kind of shape do I have going here? I've got a right triangle. So because of that, I can find that slant height. So 12 squared plus 9 squared should give me the slant height squared. Which gives me a slant height of 15. So that SLEL, or L, is 15. So slant height is 15 inches. Then for lateral, we are going to take into account pi r, which is 9, times that slant height, 15. 9 times 15 is 135 pi inches squared. So I'm going to leave things in terms of pi unless it specifies. So I'm just going to leave this as 135 pi inches squared for the lateral. And then for the total, I'm going to take lateral plus the area of the base, pi r squared. So 135 pi plus pi 9 squared. 9 squared is 81. 81 plus 135 gives me 216 pi inches squared.